This video is about lattice enthalpy. Here the introduction and calculation by Hess's law of lattice enthalpy will be discussed. Definition of lattice enthalpy. The lattice formation enthalpy is the enthalpy change when one mole of solid crystal is formed from its scattered gaseous ions. It is always negative because of bond formation. Factors affecting lattice enthalpy: the charges on the ions and the ionic radii. The charges on the ions. The charges on the ions increase, lattice enthalpy increases. Magnesium oxide has greater lattice enthalpy than sodium chloride because magnesium oxide has charge 2 plus and 2 minus. Sodium chloride has 1 plus 1 minus. So naturally magnesium oxide has greater attraction between the positive and negative ions, so it has greater lattice enthalpy. Radius of the ions. The radius of the ions increase, lattice enthalpy decreases. Sodium iodide has less lattice enthalpy than sodium chloride because radius of iodide ion has greater than chloride ion, so attraction force decreases. Calculating lattice enthalpy by using Hess's law related to enthalpy change of hydration and enthalpy change of solution. So we have to know detail about enthalpy change of hydration and enthalpy change of solution. Now enthalpy change of hydration. Hydration enthalpy is a measure of the enthalpy released when attractions are set up between positive and negative ions and water molecules. That is sodium ion, gaseous ion, plus water equal to sodium ion aqueous. Similarly, chloride ion gaseous plus water, chloride aqueous. It is always negative and it changes with radius and charge of the ions. Enthalpy change of solution. The enthalpy change of solution is the enthalpy change when 1 mole of ionic substance dissolved in water to give a solution of infinite dilution. Sodium chloride ionic crystal, water is added here, sodium chloride aqueous solution is produced. That is positive ions are surrounded by water molecule, oxygen side towards Na+. Chloride ions are surrounded by water molecule, hydrogen is towards chloride ion. It is positive or negative depending on the ionic substances. Relations of lattice, hydration and solution. Ionic solid formed from scattered gaseous ion, this is lattice enthalpy, always negative. Aqueous solution formed from ionic solid, this is enthalpy change of solution, it can be positive or negative. From gaseous ions to aqueous solution form, this is enthalpy change of hydration, it is always negative. So two arrows are in the same direction, that is lattice enthalpy and enthalpy change of solution. These two are added, we get, applying Hess's law, enthalpy change of hydration. So enthalpy change of solution is equal to enthalpy change of hydration minus enthalpy change of lattice. If enthalpy change of lattice and hydrations are given, we can easily calculate using this law. Example: enthalpy change of lattice, hydration of magnesium 2 plus ion and iodide ions are given. We have to calculate the enthalpy change of solution of magnesium iodide. Applying Hess's law, enthalpy change of solution is equal to enthalpy change of hydration minus enthalpy change of lattice. Here hydration enthalpy of Mg2 plus and iodide ions are given, but we have to multiply the enthalpy change of hydration of iodide ions by 2 because MdI2, 2 iodide ions with 1 magnesium ion, and another one lattice enthalpy of magnesium iodide negative 2327. Putting this value we get enthalpy change of solution is equal to minus 221 kilojoule per mole.